By this point, Flutter is very well known for its capabilities to create beautiful UI in a legit record time. But when it comes to structuring your code for maintenance and clarity, there's not many resources. I googled quite a bit before I made this video and found no real results for how to structure your async code or UI in Flutter. The overwhelming majority that uses Flutter pushes BLoC architectures onto devs or makes use of only the stream builder and the future builder without talking about splitting the logic and the UI. My name is Dane from FullStacks, and in this video we'll be implementing a common async situation. We'll start our implementation by using SETSTATE only and evolving that into the BLoC architecture step by step. As always, there's a written tutorial on medium.com/fullstacks with a similar title as the one you're watching now. If you'd like to follow along, head over to github.com/fullstacks/flutter-tutorials. Start and clone this repo, then open up the Flutter Basics folder and drag the Start folder into your IDE. One quick thing, please subscribe to this YouTube channel and activate your notifications. When using anything that is asynchronous in Dart, you'll have to use a future. We'll start by adding in the future that we'll be using to perform our asynchronous functionality. We'll add a function called getListData. The future will delay for 1 second and then return a list of strings. The most basic way to get state in our widgets is to call setState within a stateful widget. So we'll start by converting our stateless widget into a stateful widget. We want our future to execute as soon as we land on the widget, so we'll override the init state and call our getListData future in there. We'll add the .then callback, and when the data is retrieved, we will call setState with that data. To keep track of our data, we'll add a local variable called pageData that is a list of strings. We'll supply an empty list as its starting value. Now we can head over to the setState function in the init state, and we can set our pageData to the data that's returned from our future. The last thing to do is to display the list of data that we just retrieved. We will return a list view builder as the body of our scaffold. This list data will have an item count equal to the length of our page data, and from the item builder we'll return a container with a margin 5 with a height of 50 and a gray background. And the child of this container will be text with a value from our page data and the index that's passed from the builder. When you run this code, you should be seeing a list of containers with our titles inside of it. This indicates that our code is working, so we can move on to the next step. Next up, we'll just add a little bit of styling to make the UI look better. I'm going to add a function called getListItemUI that takes in an index. This function will return a container with the same margin and heights. We'll give it a decoration where we'll set our border radius to 5 and give it a different color gray background. And for the child of this container, we'll center the text and make it bold. We will also set the background color of our scaffold to a darker gray, and then where we currently have our container in our item builder, we can now return the getListItemUI and pass in the index. One of the key factors to providing good asynchronous UI is to provide feedback throughout its process. We'll tackle these feedback states while our setup is still simple. Let's look at the 4 states that our widget can go through. We have our busy or loading state, which indicates when the future is running. We have our data retrieved state, which is what we're showing at the moment. We have our error occurred state, which will be an error message that something went wrong. And we have our no data state, meaning that our data was fetched successfully, but we have no data to display in the list. We'll start with our busy state. We'll start by making sure that our page data is null when it's initialized. Then we'll use the fact that our page data is null to indicate that we are fetching data. We can then use this fetching data property to decide what UI to return from our build function. When the fetch data property is true, we'll return a circular progress indicator that is centered within our scaffold. When it's false, we'll still be returning our list view. We'll then update our delay time to 2 seconds so that we can see the busy indication. If you restart and run the app now, you should see a loading indicator for 2 seconds before you see the results pop in. Next up, we'll handle the error state. We'll add a parameter hasError to our future function and we'll give it a default value of false. Then within the future, we'll check if we have an error. If we do have an error, we'll return future.error and give it an error message that we'd like to see. We can then update our call in the init state and pass in hasError equals true. To catch the error, we'll provide the future with a callback using the catchError method. The callback will receive an object that's emitted using the future.error call that we added into our future. Since we are limited with this implementation, what we'll do is we'll insert the error message as the first item into the list of data, so that our list view can still render it for us. If you run this now, you should be seeing the error at the top of your screen. Next up, we'll handle the noDataState. We'll add another parameter to our getListData future. We'll add a Boolean value called hasData, and it will have a default value of true. Within the future, we'll check if the value is false. If it is false, we'll return an empty list. Then within our setState, we can check if we have any elements within our data. If the length of the list is 0, then we'll add a message into the list and set that as our page data. We can then change the parameter that we're sending in to hasData equals false. When running this code, you should be seeing the message that you set up at the top of your screen. Flutter provides us with a great way to handle all of this without needing to use a stateful widget and the setState calls. All of the code above can be replaced with a single widget, the Future Builder. The Future Builder is a widget that takes in a future and allows you to return a UI based on the future state or the information returned from the future. We'll start by changing the home widget back to a stateless widget and removing our init state override. Then we'll cut out the current body of our scaffold and replace that with a Future Builder. We'll place the old body of the scaffold into a temporary function called getDataUI, and then we'll start adding our Future Builder functionality. We'll start by supplying our Future Builder with our future getListData and then setting up an empty builder function. The snapshot variable that the builder returns to us is the information that regards the current future that's running. We'll start by checking if the snapshot has any data. If there's no data, then we assume that we are loading, so we'll return our progress indicator. If the function calls passes this check, we can then assume that we have data. We'll save our list in a local variable called listItems, and we'll return that using our list view builder. You can then go ahead and remove the old data member variable called page data. Now that that value is gone, we can update our code to use our list items that we created locally. We'll pass this list of items into our getListItem UI so that we can use it in there as well. If you run the code now, you should be seeing the exact same thing that you saw earlier. You'll see a busy indicator and then the information pops in after 2 seconds. So what changed? Well, we have no stateful widget and we don't have to call setState when we get new information. The Future Builder will call the builder function, and based on whatever information we return, it will return the proper UI. Next up, we'll handle the error and the noDataStates. We'll be using the same UI for the error and the noData message. So we'll create a function called getInformationMessage and we'll pass in a message. This function will return a center widget with a text child. We'll supply the message as our text and we'll give our text a style. We'll make our text have a font weight of 900 and give it a gray color of 500. And lastly, we'll align our text to the center. Now we can head back over to our Boulder and we can return our information messages. We'll handle error first and it will be done as the first thing within our Boulder method. We'll check if our snapshot has an error. If it does, we'll return the information message with a snapshot.error value. Then we'll handle our noDataState. When the list items has a length of 0, we'll return a message that says there's no data to display at the moment. Then we can do some quick checks to see if the UI still works. We'll set hasError to true for our getListData future, and we'll see that the error message displays properly. And we'll also set the hasData value to false so that we can see the information message for the empty data. The Future Builder is a great widget, but it has some limitations. You cannot programmatically rerun the future that you have supplied to the Future Builder. To show you what I mean, let's create a floating action button, and in the onPressed, we'll call our getListData future. This is a completely pointless call, but I just want to show you the limitation with the Future Builders. Notice that when you press this, nothing happens, and that's because the Future Builder cannot rerun that method. For this, we'll use a stream builder. The The stream Boulder works similar to the future Boulder. You provide it with a stream that can broadcast data, and the Boulder will call a build function with that information, and then you can decide what UI you would like to return. For our states, we'll create a new enum value called home view state. We'll add 3 different states: busy, data retrieved, and no data. We'll leave out the error state because our stream controller allows us to add an error to the stream. We'll then create a stream controller with a type of our enum. A stream controller is exactly what it sounds like. It's the controller that controls the stream. It allows you to put values onto the stream, and it exposes the stream for you to read those values from. Now we can change our future Boulder to a stream Boulder. We'll change the future property to stream, and then we'll pass in the stream from our state controller. As you see, there's no errors within our Boulder method, and that's because the stream Boulder uses the exact same signature and snapshot information for our stream data. We have to change our widget back to a stateful widget. So if you're using Visual Studio Code, do Ctrl-Shift-R and select Convert to Stateful Widget. And if you're on the Mac, do Command-Shift-R and select Convert to Stateful Widget. We are changing back to a stateful widget because we want our future function to run when the widget is initialized. We can now go ahead and update our Boulder function to reflect our new states. The error handling will stay exactly the same, so we'll start by updating our busy state. Instead of only checking if the snapshot has data, we'll do an additional check saying that if the snapshot.data value is equal to our busy state, then we'll show this progress as well. Next up, we can change our check for an empty list to just check if our state return is equal to no data. We will then remove our local variable list items and add it back as a member variable within our state class. We can then add back our init state override and call our future in there. We don't have to wait for or use the results from the future. The future will be emitting state values through our state controller while it's doing its processing. Now we can update our get list data future. We can start by adding a busy state as soon as we enter the function. We can then change future.error to stateController.addError, and we'll leave the message the same. We still want to return when we get an error, so we'll change our future to return a void instead of a list of strings. Then we'll handle the no data state by adding the no data enum state onto our state controller and returning. Lastly, we'll remove return from our list.generate call. We will instead set our list items equal to the list of strings that we generate. And for the final state, we want to add the data retrieved state onto our state controller. Your UI and your functionality should still be exactly the same, with one key difference. When you press the floating action button, you'll now see that the list reloads and then shows your new data. With this additional code, you've basically completely separated your business logic from your UI, even though it's still in the same file. The next logical step is to split up your file into 2 sections. We'll split our file into a model and a view. Create a new file called home model, and we'll move all of our state related code into our model. We'll move our list items, we'll move the state controller, and we'll move the enum value. We'll expose a property on the home model called home state, and it will return the state controller's stream. We can then move our future into the home model as well. I changed the name of my state controller to be private, so just update the names in the get list data future to match. Now we'll add a reference to our model in our home state file. We'll replace where we call our get list data future with model.getListData. We'll then go and replace our stream with model.homeState, and then we'll update the list view to use our list items from within our model as well. This implementation gives you a clear separation of your business logic and your UI. Let's see what it would take to get this as close to the BLoC architecture as possible. We would want to have a more complex state type. So we'll use classes for states so that we can do things like return the list of our data within our state and not have to rely on accessing the BLoC to get that information. So you can create a new file called home state, and within that we'll add a few state values. We'll start by adding a class called homeState, and then we'll add a class called initialized homeState. We'll add an additional class called dataFetched homeState, which extends the homeState. This state will return a list of strings, and we call that strings data. We will then pass it in through the constructor of the dataFetched homeState. Then we'll create a class for the error state called error homeState, which will also extend the homeState. And then additionally, for the dataFetched homeState, we'll add a property that exposes if the state contains data or not by using the data.length is bigger than 0 check. Then we can go ahead and import our homeState into our home model. We can then update our controller to take in our homeState instead of the enum. This will require you to update the future and our stream builder values. There's one state that we forgot to add, the busy homeState, so let's add that in quickly. Now that we have our busy state, we can go ahead and update our getListDataFuture. We'll pass in a new busy state at the beginning. We can then go ahead and return a dataFetched state from our noData check, and we'll pass in an empty list. And lastly, we will broadcast our dataFetched state with the list items that we generate. Now we can go ahead and update our Boulder function. We'll start by importing the homeState into the home widget. Then at the top of our Boulder function, underneath our error checked, we will store our data in a local value called homeState. We can then go ahead and check if our homeState is of type busy state. We will then update our hasNoData state to check if our homeState is of type dataFetched. If it is of type dataFetched, we can then check if it has data by using our new hasData property. Then we'll update our list view builder to get the data out of the home view state instead of using our local list items. Everything should still be the same, and we can now change our list items in our model to be a private variable so that we can only change this value from within the model. The next thing we'll look at is to limit the access to the getListDataFuture. We want our state to only be changed from within the model, and the model has to decide how that state changes. To achieve this, we'll add a function called dispatch. The only thing that the UI should be doing is telling our model which events occurred on the outside. The model will then decide what to do internally. Your UI should never be able to tell the model that it should run a future or save something. That should all be decided from within the model itself. The dispatch function we created will be taking in a new class we'll create called home event. You can create a new file called homeEvent.dot, and you can add your basic class home event, which will extend all the other events. For now, we only have a single event called fetch data, so it might seem a bit over-engineered. The point is to show that your UI can interact with the model purely through events. Because we built a reactive UI, the home UI would never have to know what the model is doing internally. It only cares about the stream with the state values in them. Within our dispatch function, we'll check if our event is of type fetch data, and if it is, we'll call our getListDataFuture. We can then set the future to be private. Now over in the home widget, we can import our home event file. We can then replace all the direct calls to the getListDataFuture with a model.dispatch, and we can pass in our fetch data event. I'm just going to add some comments to indicate what the public interface for the home model is, and then we'll additionally print out the event that is dispatched so that we can know what's happening within our model. The last thing we want to do is still be able to control our hasError and our noData values. For this, we'll add the hasError boolean as a final value, and the same for the hasData boolean as a final value. And we will also give it the exact same default values that it had. And one additional step, we'll override our toString to return the values of our fetch data event so that it's easier to track when we go through our logs. We'll format the toString so that it has the name of the event at the beginning and the rest of the data will be a JSON object with our properties in it. And as a quick check, in the floating action callback for onPressed, we will pass in the has data is false value. Then in the home model, we want to update our get list data future call to take in the has error value and the has data value from the event. When you run your code now and you open your terminal, you should be seeing the events being dispatched and the values for those events. This will help you a great deal when debugging. And if you know what the BLoC architecture is, you will see that it is very similar to what we have just created. This video was just to show you that you don't need to follow architectures exactly as it is, and you can build up over time as your app gets bigger. Not all apps and projects are the same. Not all of them require these over-engineered architectures. I hope this gives you a clear indication of how to build up your own architecture without relying on packages or existing architectures. You can build something that's custom to your app and to your project. Thank you for watching this video. Please leave a like and subscribe to get the next one.